we want to do this one, but we are running out of time. Okay, this one you can do at your own time. And you can share your answer in Teams. I can review for you. Okay, please try this one. So today I will proceed to Simpson 1/3 rule. Got ready the question? Okay, let D be 4. Okay, just put as 4. Okay, so this one for trapezoidal. Today we'll proceed to Simpson's 1/3 rule. Okay, Simpson 1/3 rule. Before that, trapezoidal, the minimum point is 2. Okay, trapezoidal minimum point is 2. But for Simpson, 1/3 minimum point for Simpson is 3 points. Okay, for Simpson, minimum is 3 points, which equivalent to n equals to 2. Okay, so if the question mentions single application, n is 2. For single application, Simpson 1/3. Okay, single application, Simpson 1/3 rule. Minimum n equals to 2, which you are required to have 3 points. Okay, this is 1/3. Okay, 1/3. So minimum 3 points. 2 sections. Okay. Okay, so A is 1/3. B is Simpson's 3/8. Where Simpson 3/8 minimum n equals to 3. Okay. Single application for 3/8 n equals to 3. This one is the minimum, which requires 4 points. Okay, in previous final exam, I just mentioned apply Simpson's 1/3 single application. I didn't mention the n. So you should know what is the n. Most of the students got it wrong because they use wrong n. Okay. Okay, again I emphasize Simpson 1/3 single application n equals to 2. It must has minimum 3 points. Okay. Now, the equation, the function for Simpson, it used Lagrange polynomial. Trapezoid last time it used Newton. This Simpson it used Lagrange. The first part over here. Okay. Now this is the integration for Simpson 1/3. Okay, Simpson 1/3. H over 3. Trapezoid last time. Okay. Trapezoid. We have what is it? Trapezoid. BA multiplied by FA plus FB over 2. Okay, that one is single application for trapezoid. Okay, but for Simpson 1/3, notice the difference. H over 3. Okay, H over here. Remember, H is B minus A over N. Okay, always like that. Focus, even though you cannot grab, just focus. Okay. Then, this is the equation for Simpson 1/3. For Simpson 1/3, the intermediate part multiplied by 4. Okay, remember that we have at least 3 points. Okay, so this fx1 multiply by 4, the intermediate part. Okay, 6 here is because of 2 multiplied by 3. Okay, we know that h, okay, h over here, some of you might confuse. H over here is b minus a over n. Okay, initially this one over n, which this n is equals to 2. Wait, I do it again. B minus a over n. Okay, fx naught plus this one. Over 3. This is for 1/3 rules. So 1/3 rules, we know that the n minimum single application is equals to 2. Okay, so that's why it becomes to this equation where divide by 6. Okay. Now the error, we just fix to the true error that you always use. Now, we try this one example so that you understand how to apply Simpson 1/3 rule. This question, it doesn't mention the n as well. So we assume single application. Okay, we assume single application which n equals to 2. Okay, if it doesn't mention, you can put your own assumption. Here, because we only touch the single application, so we use single application. If later, let's say, we already touch the multiple application, you can assume how many n's that you want. Okay. Now, identify your A and B. This is your A. This is your B. Okay. Then, this part is your function. Yes. 1/3, it needs minimum 3 points. 1/3, minimum 3 points. So 3 points, n equals to 2. Okay, that's the rule for Simpson. Okay, first thing, find the h. B minus a over n. Okay, your b is 1.3 minus 0.1 over 2. 0.6. Yeah, correct. Sorry. 0.6. Okay, 0.6 for the h. Now, your points. Next, identify the points. 3 points. So x0, x1, x2. x0, what is it? x0. 0.1. Okay. x0 referring to your A. x1. x1. 0.1 plus 0.6. Okay. So 0.7. x2. 1.3. Okay. x2 must be your B. Same as your B. Then subs the x value into the equation of this. This is your fx. You can set the equation in the calculator, then just input the x value. It will be faster. What if fx1? Again, fx1, fx1. 0.8631, fx1. Okay, 0.8631. How about fx naught? Okay, I will take as 0.4094. Okay, just keep it as 4 decimal point. Now fx2 would be 0.4828. Okay, then third step is to sub all the values into the equation, which 1/3 Simpsons your H is 0.6. Correct, 0.8689. Okay. Now find the true value. You can find the true value for this function so that you know whether your answer is approaching the true value or not. What's the true value that you get? True value, use calculator. What you get? True value? Correct. 0.8939, true value. Okay, so from here, calculate your true error. The question doesn't mention, but I want you to know, I want you to calculate the true errors. What do you get? True error, what you get? Yes, 2.8. True error is 2.8. Okay, please let me know if you're stuck somewhere. I can repeat. Okay. Okay, I repeat again. Simpsons wanted, okay, Simpsons wanted the minimum point that we need is 3. Okay, so that's why when 3 points, you will have 2 segments, 2 sections. So that is the minimum single application. Like trapezoid, minimum application n equals to 1. Okay, Simpson, minimum n equals to 2. Okay, so this is the final answer with true error of this. True value, this. Okay, clear? Okay. Calculator.
Okay, which one?
The function, using the function.
Substitute the function.
The function given. This one, the function. This is the function. Okay, how to find true value? Again, using calculator, function integration, sub in your equation. Okay, this is your equation, fx. Okay, 5 exponent. I will advise to use bracket. Okay, negative 2 x, comma, put your range 0.1, then 1.3. Okay. Okay. Namir, okay? Okay, now I move to multiple application. Now, multiple application, this is the rules. Sorry, this is the equation, multiple application. Okay, this one. Okay, notice the intermediate part. Now, the intermediate part, which is this, you have 2 sections. The odd one, the odd section, the odd segment, multiply by 4. Okay, the even segment, multiply by 2. Okay, there are odd and even. Okay, we try one example. Now, this one. We try one example. I extracted from the textbook. It asks you to use equation, this one, the multiple equation with n equals to 4. Okay, to estimate the integral of this function from a to 0.8. Okay, the same as previous example, but now we use 1/3 rule. Okay. Multiple application, n equals to 4, multiple. So, first step, what do you need to do? Find your h. First step. B minus a over n, which is 4. 0.2. Okay, your h is 0.2. Second step is to find your point. Four segments, how many points? 5 points, correct. Okay, so your axis, x naught is a, which is 0, x4 is b, which is 0.8. Now, what are the intermediate values? X1, correct, 0.2, according to your h. Okay, so add in x1 plus h, you will get 0.4, 0.6. Okay, your final point must be 0.8. If let's say x3, you add h, not 0.8, then something wrong with your data. Okay. Then from there, find your f-axis from the given equation over here. Set the equation in your calculator, then input the values. Okay, let's try. Set the equation. Okay, once you set your equation, press calculate. Input your x value. First, 0 equal. Okay, so you get 0.2. Next one, calculate. Don't press AC. If you press AC, all the function will be deleted, the equation, okay? So, x is 0.2 equal. You get your value. Okay. In the assessment, test or midterm or final, doesn't matter if you want to bring 1, 2, 3 calculator. As long as calculators, not smartwatch or anything, okay? Because perhaps one calculator, you set one equation. to find the fx. One calculator you set to find other equation. Okay. Okay, all get the values of fx. Tang Sui, you get the value of fx. So once you get the value of fx, sub into the main equation. Okay, integration. H, okay, your H is 0.2 over n. N is 4. Sorry. Over 3. Sorry. Okay, H over 3. This is your H. B minus A over N is your H. Okay, then sub fx naught 0.2. Okay, this part, odd numbers, sorry, odd data points. Odd, Now careful. X1, odd, okay. 1, 3. That one multiply by 4. Okay, then even data points. Okay, now these even data points. Focus on even data points. X2, X4. You have X2 and X4. So even data points, which data points must be multiplied by 2? X2 only. X2 only. Because X4 is your Fn, the last value. Okay, plus your Fn or Fb, which is the last value. What you get? What you get? I already bring 3 outside. Here. N, okay, B minus A over N is your H. This is your H. Okay, H over 3. Do you get 1.6235?
Yes.
Okay.
We have 4 points. We use the same formula for single number.
4 points.
Yes, that's it. Like x1, x1, x2, and x3.
4 points equivalent to n equals to 3. Right?
So there's a different formula for it.
Same formula. Multiple, use this formula. Single, only you use the previous one. Yes. Okay. Okay, if no question, I move to Simpson's 3.8. Any question for Simpson 1/3 just now? Remember, single application n equals to 2. Okay. Simpson 3.8, single application, which is this. Okay, this is 3.8. Equals to 3. Single application of Simpson 3.8 n equals to 3. Minimum, you should have 4 points. Okay, Simpson 3.8, minimum to have 4 points. Okay, then the equation change to this. Now you have 3.8. Same, this one. Okay, this it use directly the h. This one it expand b minus a over n. Okay, both are the same. It used 3/8. In 1/3 just now, it used h over 3. Okay, now 3/8 multiplied by the h. Now for Simpson 3.8, multiply by 3. Single application. Okay, the intermediate multiply by 3. 1/3 just now multiply by 4. Okay, this one multiply by 3. Okay, so we try this. Simpson 3.8 rules. For A, 3.8. It doesn't mention what is the n, so we assume single application. Single application n equals to 3. Okay, so your h, this is for A. H, find your h. First step to find your h. 0.262. Correct. Oh, okay, then we take 0. 267. 0.267. Okay, just take it as 0.267. Then find out your points. 3, so you should have 4 points. Single application. A 0, B 0.8. Zero 0.533. Okay, here is the answer actually. You see the solution. X0, X1, X2, X3. Okay, Fx. Okay. Okay, so subs in the equation. You will get this value.
H 0.267 is 0.801. That okay?
Acceptable. 0.801. Acceptable. Huh? Okay. Okay, clear? 1/3 and 3/8. Now, this one, wait, let's see. So for B, B is 1/3. Okay, now I want to proceed to this. This is the summary of those three integration methods. Trapezoid, Simpson 1/3, and Simpson 3/8. Okay, trapezoid rule, every 2 points. Minimum for trapezoid is 2 points. Okay, that's why it can have this series of n. This series of n can be used for trapezoid. Each 2 points, you can use the trapezoid. Okay, so this is the equation for multiple application. Okay, multiple. Now, Simpson 1/3 every 3 points. You must have 3 points. Okay, so that's why minimum n is 2. Okay, if n equals to 4, you have 5 points. Okay, let's say you have 5 points. Okay, Simpson 1/3, n equals to 4. You have 5 points. 1/3 minimum 3 points. So 1, 2, 3. 1 Simpson 1/3. 1, 2, 3. You have another Simpson 1/3. Okay. Now here, it doesn't mention 5. Why? N equals to 5. Let's say n equals to 5. For example, we take this. Okay, n equals to 5, you have 6 points. 1/3, it requires minimum 3 points. Okay, 1, 2, 3. 1/3, 1, 2, 3. 1/3. This point, you cannot use 1/3 rules because it left only 2 points. Okay, that's why n equals to 5 is not included here. Cannot be 5. 1/3 every 3 points. Okay. Same thing for Simpson 3/8 every 4 points. Okay, every 4 points. Okay, let's say 4 points means every 4 points are 1, 2, 3, 4. Minimum is n equals to 3. Here you can use 3/8, single application. Okay, let's say n equals to 5 as well. 3/8 it requires 4 points. If n equals to 5, first part you can use 3, 8, but the next 3 point, 1, 2, 3, not enough to use the 3, 8. Okay, this one cannot use 3, 8. So that's why n equals to 5 is not included here. Because Simpson's 3, 8 requires minimum 4 points. Every 4 points. Okay. Now you should understand the n over here. Because let's say I mention n equals to 9. Integrate whether using trapezoid or Simpson. So which Simpsons that you need to use? N equals to 9. Simpson 3, 8. Simpson 1/3 can n equals to n equals to 9. Let's see. Okay, let's see. We try. N equals to 9. Let's see if 1/3 can use or not. 1, 2, 3. Okay, 1/3. 1, 2, 3. Cannot, because left only 2 points. So n equals to 9 cannot use 1/3. It's either trapezoid or Simpson. Simpson 3, 8. Okay. Now this equation, the last equation is for Simpson 3, 8 multiple application. Okay, multiple Simpson 3, 8 even complex. Take note on the data points over here. Okay, so this set of data points, you must gather them correctly. Okay. Any question so far? So for integration, trapezoid, single multiple, Simpson 1/3, single multiple, 3, 8, single multiple. Okay.
So, 8,
n equals to 5, yes, trapezoid. Only trapezoid can be used. Sorry? The accuracy level? Yes. More points better. Different rules also have different accuracy. The higher the points, the higher the accuracy. So in general, Simpson 3, 8 requires more points. Okay? Can also. If multiple application of trapezoidal, you will have a higher accuracy as well. Because you have more points.
Last point, what?
Last point?
More points.
It depends. More points, yeah. More points. Because Simpson 1/3 and 3, 8, it has its own rule. So it is limited. Whereby trapezoidal, each point you can use the trapezoidal rules. Each segment. And it also depends to the original function as well. Okay, from here, okay, Julius, from here, this kind of function, okay, this function, okay, this curve. If you do 1/3, 3 points, so you have this error. Okay, if you use 4 points, then lesser error. Okay, but if you use trapezoid, the error will be lesser as well. Let's say trapezoid n equals to 4. Okay, sorry, n equals to 3. Trapezoid n equals to 3. So you will have trapezoid area under the curve. Okay, so different rules, different accuracy level. But in general, the more the points, the higher the accuracy. Okay. Okay, so we move to unequal segment. Unequal means that we combine all integration rule. Okay, let's say you have this curve. Okay, let's say you have this curve. So you can combine all rules. You can either use only trapezoid, no issue, or you can combine all rules to improve the accuracy. Okay, so in this example, it used trapezoid rule for the first segment. Second and third segment, it used 1/3. Then the rest of the segment, it used 3/8. Okay, so here, total integration is the summation of integration using trapezoid plus integration using 1/3 plus integration using 3/8. And remember, each method has their own equation. Okay, the last point, it used trapezoid. Doesn't matter which method you use, summation, you must sum all. Okay. You can try for one question using all multiple or all 1/3, all 3/8. Or you can try to mix. Then you can see how is the accuracy. Okay. This equation, sorry, this example, can I proceed? Julius, any question, any doubt? Can I? Okay. Now this example, it used two methods. This is a multiple trapezoid. Okay, it will get this value. Okay, this example I explain only. We will do the next final exam question. Now this multiple trapezoid, it gets this value. Which another method it use, this is multiple Simpson. Multiple 1/3. Okay, and it gets this value. Okay, so you can see the difference when you use multiple trapezoid and multiple Simpson. Okay, it difference. The value it deviates quite a lot. Okay, 5, 7, 5, 2. Okay. We try to do this question. Just proceed with 3, 8 rules. N equals to 9. Okay, proceed with this only. Simpson 3, 8. N equals to 9. This is the function given. Your A, B. Okay, so find out your H, then find out your points. N equals to 9, so you should be having 10 points. Okay, when you have many points, please be careful. X naught is 0, x10, which is your final point, should be pi over 2. So in between numbers, yes.
The H is 0.17.
0.1.
74.
What mode did you use? Radian mode. The rest get what? Same. 0.174. Okay, let's see. Sorry? Which one?
I did for N equal to 9.
N equals to 9.
Yeah, I got 0.
Wait. 0.174. Right. Sorry, the 17 is n equals to 10. Sorry. My mistake. Mm, 0.1745. Okay, try to find out your points. This question by right is to both 10 and 9. But since we don't have enough time to do both, just do N9 section CA. Okay, make sure you use the correct equation. Simpson 3/8. This is the equation. You can expect this kind of question for your test. Yeah.
How many questions are like the test?
Test will cover cell 3 and 4.
Normally 2 questions.
2 or 3 lah.
Enough time?
Nah.
No.
I will design question based on the timing also lah. Okay, that's why it's important for you to practice so that you are familiar how to use the calculator. Okay, how to know your answer is correct? Always find the true value. Okay, true value here, this thing. If your answer approaching that value, then your answer should be correct. You get all the fx already? Okay, stop first. Okay, stop this exercise first. Later you proceed on your own because I want to show you the example of unequal integration. Unequal integration. Okay, this is from test May 2023 for B. B. Okay, we focus on the B. A we haven't done. A you can try on your own. Now this question, it asks you to apply both Simpson 1/3 rule and trapezoidal rule to solve the integral, including the true error. Apply both. So you should combine Simpson and trapezoid. Okay? Means over here, n equals to 2, n equals to 3. So what this question means is, you have in total of 5 segments. Okay? 2 segments, you can use 1/3. Okay, 2 segments here, it can be first 2 or the last 2, up to your selection. Okay, let's say we choose first 2. First 2 use 1/3. Okay, so the last 3 segments use trapezoid. This is what the question means. Apply both Simpson and trapezoid, and not all. So in completing the integration, you should combine. This is unequal segment. So 1/3 plus trapezoid. Later on, the integration, total integration, will be the integration of 1/3 plus integration of the trapezoid. Okay?
Use to Like one certain one,
Sorry?
we went to
To answer,
one or lots of.
yes, actually, yes, can. Because this question is not quite specific. So there are few types of answer. This one, which you combine, or the next one, you use one integration of 1/3 and another one integration of trapezium with n equals to 3, n equals to 2. Okay? But my intention initially is for you to combine Simpson and trapezoid like this. But from when you read the question, you can, sometimes you can describe your own meaning, whether to combine or fully Simpson 1/3 and fully trapezoid and 3. Okay.
So n equals 2.
No, because the question already mentioned trapezoid must use n equals to 3. Okay, it's either first 3 or last 3. Okay. Okay, so we are done integration. Trapezoid, Simpson 1/3, Simpson 3/8. All you must know single and multiple application. Okay. Okay, wait, another one. Just to, okay, here. Okay, this question, you see, it doesn't mention what Simpson. Compute the integral using Simpson's rule when n equals to 9. So it doesn't mention 1/3 or 3/8. This equation not provided lah for the question. Okay. This one I used to do the solution. Now, Simpson's rule, n equals to 9. You need to know which Simpsons to be used. How to know? Not simply by memorizing the table just now. Okay, you should understand. If 9 you have 3 points. Sorry, 9 you will have 10 points. Sorry, 10 points. So let's say 1/3. 1/3 minimum how many points? 3. Okay, 1/3 minimum 3 points. 1, 2, 3. Okay, 1/3. 1, 2, 3. 2 segments lah. Okay, every 2 segments you can use 1/3. Okay, but this one you cannot use 1/3. So 1/3 is not valid to be used for this question. Okay, 3/8 minimum 4 points, which is 3 segments. Okay, so 3/8 is valid to be used for this equation. Now for this question, okay, n equals to 9. It depends. Sometimes mention, sometimes doesn't mention. So you need to understand. Okay. Any question for integration?
So means that if you don't know what we real statement, we can always use the trapezoid.
This question clearly asks you to use Simpson.
Is the question didn't mention.
Can? If the question just put general integration, you can choose either trapezoid or Simpson. Okay, so that's all for integration. Next class after your midterm, we'll proceed with differentiation. Okay, that's all for today. Good luck for your midterm tomorrow.